My topic is about conditions to occur deadlock and prevention of deadlock. First, we have to know what is deadlock. The process waiting for the resource continuously, but resources are not available or allocated. The situation is also known as deadlock, holding and requesting for the resources. Deadlock mainly occurs in the four conditions: mutual exclusion, no prevention, hold and wait, and circular wait. Mutual exclusion. In this, we will discuss about resources. There are two types of resources, that is shareable resources and non-shareable resources. Shareable resources. More than one process can utilize same or particular one resource at a time. For example, files. Files can be utilized one or more processes at a time. Non-shareable resources. More than one process can utilize the same or particular resource at a time. For example, printer. Printer can be utilized one processor at a time. At least one resource should be non-shareable, then mutual exclusion occurs. No prevention. If a process is holding the resources, it doesn't leave until it's completed. For example, let us take the processes P1 and P2. Resources R1 and R2. P1 is holding the resource R1, P2 is holding the resource R2. But P1 is requesting the resource R2 and P2 is requesting for the resource R1. Hold and wait. Holding the resource and waiting or requesting for the another resource. P1 is holding the resource R1 and still it is waiting for the resource R2. Circular wait. Let us assume n processes P1, P2, P3 and so on P of n. P1 is waiting for the resource which is P2 and it is waiting for the resource P3 and so on, and P of n is waiting for the resource P1. Deadlock prevention. Deadlock will not occur even one of these conditions is not satisfied. Mutual exclusion. Mutual exclusion cannot be avoided by the default. Few resources will be non-shareable. Example, printer. Hold and wait. We solve this problem with two solutions. Solution 1. Allocate few resources at the beginning of execution. Although we require the resources that prevent previous resources, request for the resources that are required. And the drawbacks is it is a low utilization of resources. Example, copy the data from DVD drive to disk file, sort and print. And the solution is allocate the DVD drive disk file after completion of usage with DVD drive and disk file, then leave or prevent the both resources. And then again the processes will request the disk file and the printer. Advantages: utilization resources efficiently. The drawbacks: the starvation and the file may change or modified or utilized by the other processes. No prevention. Let us assume the P1 is a process. R1, R2, R3 are the resources. P1 is holding the R1, R2 and P1 is requesting for the R3. If R3 is available, then allocate, else. There are two solutions. The first solution is take away the resource from the P1. If all the resources R1, R2, R3 are available, then P1 start its works. Second solution is if P2 is requesting the R4 and holding the R3. If P1 is requesting R3, then it prevent it from the P2 and allocate it to the P1. Circular wait. F from R to N, it is a one-on function. If the resources allocated to the process according to the ascending order. Example, if the processes request printer first, then it doesn't request for DVD drive and stays in the loop.